Hi, math classes. Today we're going to do 1.8 US shirts using tables, graphs, and equations. So here's the scenario. Is this past summer you were hired to work at a custom t-shirt shop, US shirts. So one of your responsibilities is to find the total cost of customers' orders. The shop charges $8 per shirt plus a one-time charge of $15 to set up a t-shirt design. So what we need to do first is likely maybe figure out what our slope is or our rate and what is our one-time starting fee. So the problem asks you to describe the problem situation. So looking at it, you are going to have to charge $8 per shirt. So $8 per shirt. And then you're also going to have a one-time fee of $15. So how does this problem situation differ? Go ahead and answer that. So pause me, answer that, and then check back on the answer. So how did the problem situation differ from the problem situations in 1.6? Well, in 1.6, that was the patio furniture problem, and we had 8H equals our earnings, right? And H being our time worked, our hours. So if you notice in this one, we actually have a one-time fee of $15. So for this one, there is a setup fee. Again, you should be taking notes in your math encyclopedia. So looking at this, it says, what's the total cost for 3 shirts? Pause me and answer that question, then hit play and get the answer. So if I go ahead and say, okay, there are $8 per shirt, and I know that there are 3 shirts, so it's going to be $8 times 3. That's going to give me 24. But I'm not done. I need to add that $15 fee. So the total for 3 shirts is $39. How about 10 shirts? Again, hit pause, figure it out, and then hit play. So it's going to be 10 times 8, because that's my fee, is 80, but then I got to add that 15, and that's going to give me 95. What if it's 100 shirts? Well, again, you would do $8 times $8 per shirt times 100 shirts, and you would get 800 plus that $15 startup fee is $815. So a customer has $50 to spend on t-shirts. How many shirts can the customer buy? Well, let's look at making an equation for this. So what if we had that handy dandy y equals mx plus b? M is my slope. That's the rate. That's what you're going up by each time. B, that's my y-intercept. That's my starting point. But what are my variables? What's my y and what's my x? What are we figuring out? Well, I'm solving each time. Like before, I was solving each time for, looks like a dollar amount, $39, $95, $815. So each time I'm adding and multiplying and adding to get that total cost. So it looks like here is going to be my dollars, or my cost for the t-shirt. Dollars is my units. And then here it's going to be the amount of t-shirts. And my unit there is going to be t-shirts. So what is my slope? What am I going up by each time? So I know y equals, well, thinking about what I'm multiplying consistently by my t-shirts was 8 times my x plus, and my starting amount is 15. So my whole formula is y equals 8x plus 15. If you want to use cost for that, that's fine. If you want to use S for t-shirts, that's fine. So looking here, a customer has $50 to spend. So basically, I'm going to plug that in here because I want to know if I have $50 to spend, how many t-shirts can I buy? Well, here's those basic skills of solving linear equations. So remember what we do. We box, subtract 15 both sides. There's more on the floor, so I got to borrow from next door. 10 minus 5 is 5. 4 minus 1 is 3 equals 8x. Well, does that go in evenly? No. So let's count by 8s to figure that out. 8, 16, 24, 32. So I know for a fact I can buy $32 would get me 4 t-shirts. But I can't buy, and I'll have a little extra money left over because I can't buy 4.375 worth of t-shirts. So I'm only going to buy $4, 4 t-shirts rather. And I can't go over that limit. Same with the next one. So we have 60 equals 8x plus 15. Subtract 15 both sides. More on the floor, I borrow from next door. 10 minus 5 is 5. 5 minus 1 is 4 equals 8x. Again, I'm going to not get a whole number because if I divide both sides by 8, well, 45 divided by 8 is going to give me 5.6 something. So I can't buy a partial shirt, so I'm only going to be able to buy 5 t-shirts. And the last one is 220 equals 8x plus 15. Subtract 15 both sides. I'm going to write this over here because I can't really see it. More on the floor, I got to borrow from next door. 10 minus 5 is 5. 1 minus 1 is 0. 2 minus nothing is 2. 205 equals 8x. If I divide both sides by 8, x is going to be about 25.625. So that means I can only buy 25 t-shirts. So let's go ahead and figure out the table. I'm going to go ahead and give you your x's. 3, 4, 10, 25, 100, 120, 150. Go ahead and figure out what your total cost would be. Go ahead and check your answers with mine. Go ahead and answer these questions on your own. Hit pause, answer the questions, and then when you hit play, I'll have the answers ready for you. Go ahead and check your work. Remember that dry mix. Independent is going to be your X, which is number of shirts, and your dependent is going to be your Y, which is your cost. Now we're ready with our bounds chart. So looking at number of shirts and total cost, we can tell that our lower bound is always going to start at 0 and 0 from now on. And then upper bound, well, looking at our data, we need to go up to about 150. We have 15 lines, so it sounds good if we start at 150 and do an interval of 10, and then 1500 and do an interval of 100. Go ahead and check your graph against mine. Again, mine is not beautiful. It's really hard to do on a tablet, but you can get the idea of it. Oh, and don't forget a title. Good job, guys, and homework is on.